Good day, class. Today, we will discuss two very important components in digital systems, the analog-to-digital converter, or ADC, and the digital-to-analog converter, or DAC. The real world is mostly analog. Digital systems work using numbers, specifically ones and zeros. ADC and DAC are like translators. They help digital systems understand the real world and help the real world understand digital commands. An analog signal changes smoothly and continuously. Examples: temperature rising gradually, light brightness changing, sound waves. These signals do not jump between 0 and 1. They have infinite possible values. A digital signal has fixed values, usually represented as high or low. Digital systems process data as numbers. This makes digital systems accurate, stable, and easy to control. An ADC converts an analog signal into a digital value. It takes a real-world signal. It turns it into a number the system can understand. Without ADC, a digital system would be blind to the real world. Examples: reading temperature, measuring light intensity, detecting sensor values. ADC allows sensors to talk to digital systems. The sensor produces an analog voltage. The ADC samples the voltage. The voltage is converted into a digital number. The higher the voltage, the higher the number. The system then processes this number using software. Resolution tells us how detailed the ADC conversion is. More bits equals more precision. Higher resolution equals more accurate readings. Think of it as reading a ruler with more markings. A DAC does the opposite of an ADC. It converts digital values into analog signals. This allows digital systems to control analog devices. Many devices need smooth, variable signals. Examples: audio speakers, motor speed control, light brightness control. DAC allows digital commands to become real-world actions. The digital system sends a number. The DAC converts the number into a voltage. The voltage controls a device. A higher number means a higher output voltage. ADC brings the real world into the digital system. DAC sends digital decisions back to the real world. Example: sensor ADC digital processing DAC actuator. This loop is common in automation and control systems. The temperature sensor uses an ADC to read heat. Digital controller processes the data. DAC outputs a signal to control a fan. This is how digital systems react intelligently. ADC is not a sensor, it works with sensors. DAC does not store data, it outputs signals. Both ADC and DAC are essential in mixed signal systems. These concepts become clearer with hands-on practice. In robots and control systems, ADC and DAC are everywhere. Examples: reading sensor data, controlling motor speed, and audio adjusting light intensity. Without ADC and DAC, robots would not function properly. The real world is analog. Digital systems work with numbers. ADC converts analog signals into digital values. DAC converts digital values into analog signals. Both are bridges between the digital and physical worlds. If a robot detects light using a sensor and adjusts its speed smoothly, where do ADC and DAC fit in that process? Thank you.